Carlsbad, New Mexico, in the foothills of the Guadalupe Mountains. More than 1,000 feet beneath the desert floor, 3 scientists journey into the unknown. They have come to this pristine underworld to collect bacteria and analyze the chemicals the bacteria produce. From the chemicals, they hope to make new drugs to use in the fight against cancer.
We're using the caves here in New Mexico as a source for new microbes, bacteria and fungi, which we hope will be the source of new drugs to treat human disease. The uniqueness of our approach is where we're getting those chemicals, and that's the cave microbes. Our goal is to identify microbes that are making chemicals that we can isolate and use to treat cancer in a better way than we're currently treating cancer.
The scientific odyssey that brought this team to the caves of New Mexico began more than 1,000 miles away at the University of Vermont's Cancer Center. Here, drug developer Miles Hacker leads a research team in the war on cancer. Their goal is to find drugs that are harmful to cancer cells, but not harmful to patients.
What we're doing is we're randomly going into caves and selecting bacteria from those caves and then growing them up and then randomly testing the broth. Every broth that you put with a tumor cell has the potential of being a new anti-cancer drug. So you can feel the excitement just when you're putting each sample in with the tumor cell. One of the unique things at the University of Vermont and the Vermont Cancer Center is that it is a small school and a relatively small cancer center. And we basic scientists work closely with the clinical scientists, so we're constantly interacting with physicians and discussing the diseases. So there's always this motivating factor. There's always patient interaction. The problem with chemotherapy, drug treatment thus far, is that we don't have a lot of selectivity in our drugs. All they do is they recognize dividing cells. In our body, if you have cancer, you have cancer cells that are dividing, but you also have cells in your bone marrow, cells in your intestine, cells in your scalp, your hair cells are also all dividing.
Good girl, Nikki, all done. All right. Are you going to take home the pink kitty with you? All right.
Unfortunately, the cancer drugs don't know the difference. And when a person is treated with these drugs, we see a lot of toxicity in the patients because the drugs are not selective. We have patients lose their hair. And all of this comes from the relative lack of selectivity of the drugs that we have to treat the disease.
It might hit the tumor.
All organisms have to some extent fight with each other, and a lot of them, if they can't run away and don't have teeth and claws, they use chemicals to fight with each other. And in caves, there's really nothing to eat. There's no sunlight, there's There's no photosynthesis. So caves, organisms, microbes must fight with each other with chemicals.
Nature has been at war with itself in terms of chemical defense and offense ever since the first cell crawled out of the muck. It's, how do you keep the outside out and the inside in? All sorts of chemical tricks. How do you compete? Often chemically. And this competition in defense has been going back and forth for billions of years. And the chemistry involved, the selective pressure that's been involved, and the diversity that has evolved is tremendous. And we have only begun to just tap the smallest fraction of that, which has given us many antibiotics, which has given us certain cancer treatments.
Microbes survive by not allowing other microbes to live, and they stop cells that are dividing. Microbes, basically, their only goal in life is to make more microbes through cell division. And it's a logical extension that if the microbes survive by stopping other cells from dividing, they should be making chemicals that will also stop tumor cells from dividing. Basically, it just lets you know that there's constant battle going on. The body wants the tumor to stop dividing, the tumor wants to keep growing, the bacteria wants to keep its enemy from growing, the enemy wants to keep growing. So there's constant battle going on. And what we're trying to do is use that battle in our battle against tumors. The unique thing of Larry is that he's one of a very small population of scientists who actually can be considered cave microbiologists. Larry is one of perhaps 3 or 4 individuals who can actually go down into caves and selectively and successfully isolate bacteria and fungus from the cave setting. His genuine enthusiasm for caving and microbiology results in an individual with a lot of enthusiasm for our project, and it takes a lot of enthusiasm to stay with it. Jim Bigelow is also a person who genuinely loves to go into caves. He provides with our group a significant expertise in chemistry. The isolation of the chemical and the chemical characterization of that chemical are absolutely essential for the success of this overall project. What makes it really a nice partnership is that we all have complementary expertise. I've got about 20 years of experience in drug development, and consequently I've been through the highs and lows of chemical isolation and drug development with respect to cancer chemotherapy. So I think I have the expertise that's needed to identify important chemicals for drug development. Sometimes not all the dry broth wants to go back into solution. And that complements nicely with Jim's expertise in chemical characterization and Larry's expertise in microbial isolation. So between the 3 of us, we've got the 3 major bases covered. Well, actually, I came here from Kansas City. I had a job in Kansas City, Missouri at a research institute. There was an advertisement for someone who was a pharmacologist and a toxicologist. So I applied, and my family moved up here. My wife and I moved up here. At the time, we had no children, so we moved up here. It's very difficult to do the work that we do if you don't have some sort of support system. You do put in many long hours, and you come home sometimes extremely frustrated, and it does require a lot of understanding of your family. My family has been unbelievably supportive of our effort. To be honest, the reason I went into pharmacology was that it's a field which allows us to try to use science in an applied way to try and decrease suffering of humans. What really got me involved in this whole research area was my time at graduate school down at St. Jude Children's Research Hospital, a hospital set up by Danny Thomas back in the 1960s. The goal was to try and develop ways to cure childhood diseases. At that time, the focus was childhood cancer. It was a small hospital at the time, very small, 1 floor. And when I walked from the front door to my lab, I would walk by the clinic, and you could see the children waiting for therapy or undergoing treatment. And it was really quite dramatic to see that sort of thing with the 3 to 5-year-olds being treated with rather rough chemotherapy and bravely taking on the disease and the treatment. So when you see that sort of thing and you're working in trying to develop better cancer chemotherapy drugs, it really gives you a drive to keep working.
I'm Rosemary Botten. This is my husband Tom, son Jeffrey, and Jeffrey was diagnosed with ALL, leukemia.
Well, my name is Diana Anderson, and hers is Nikki Anderson, and she has ALL, leukemia, and she's doing a lot better now.
With the shots and the spinal taps and just the overall treatment that he has to go through, I think that's the toughest part. And
you'd rather do it yourself.
Yeah, if you could trade places, you would in a heartbeat, but...
The last time she was in the hospital, her last stay, she had no hair, and after that, after they stopped, I guess, the big bags of treatment, her hair grew back real fast. You'd think about when their hair's falling out, you get scared, but it didn't bother her at all. She might, in fact, we do a teaser, about it.
Your first 28 days are the absolute hardest. If there is hell on earth, put a parent through the first 28 days of chemotherapy treatment because they have to get them in remission, and just the drugs that you have to give them are terrible, and there's no other way around it. But if you can make it through that, the rest of it comes a lot easier.
The hardest part is when she couldn't walk. She'd be in pain from the chemo, and I couldn't do anything. And she would be, I guess, sort of angry because she knew that I couldn't do anything. Actually, she was a lot better than I was. She seemed to pull through better than me because she would tell me not to worry. Right?
Take this in. Okay, that's the bucket. Get something there. Tuck and roll. Got it.
In New Mexico, on the trail of cave-dwelling bacteria, Hacker's team explores remote regions of the popular Carlsbad Caverns, areas few tourists ever see.
Quick, I know you want to get going. We stop everyone before they enter the cave for a couple of reasons. Number one, we want you all to understand that the walk down is a serious walk. In a mile, you will descend about 800 feet. If there's anyone among us who has poor health or who has difficulty walking, you probably would be better off using the elevator. That's just an advisory.
At Carlsbad Caverns, the team are the guests of the United States Park Service. They're provided with living quarters and most of the comforts of home.
Trip going, we've got the time, we've got the people. As long as I don't slice the tip of my finger off here, we don't...
I'll guard the camp.
No, you're not getting off that easy.
You're coming with us this time.
We really need to talk about the National Park Service. They are as important as the rest of us because what they provide us is access to pristine environments, the environment that we defined as our target.
Yep. Okay. Let's see.
So Larry, you still eat hamburgers, right?
Yeah,
okay.
Oh, definitely.
And Jim, you wanted yours medium well or medium rare?
Medium rare, please.
Larry?
No, medium.
Okay. You all get them well done. And it's been unbelievable, the cooperation that we've gotten from the National Park Service in our work here, and I think it's a symbiotic relationship, and I think that they're also involved in helping discover new drugs.
Oh, an industrial tub of ketchup.
Yeah, that's
That'll do.
Okay, Mark 1089. Go ahead.
Good enough. It is.
Yeah, it is.
Ketchup doesn't go bad.
Well, we'll find out.
I've had ketchup in my refrigerator for about that long.
There's nothing wrong with you.
Debatably, perhaps.
Yep.
Might as well.
Yep. I do now. Mine is much easier to just accept what you
Yeah.
Usually 50 burger miles.
Yeah.
Dr. Jim Bigelow takes charge of the team's equipment. He plans for the worst. Each team member must carry 3 working lights.
It's for the same reason that he likes his analytical chemistry. He's got all these little doodads to mess around with all the time. You watch him in the lab and he's in heaven when he's got his 3 or 4 HPLCs in mass spec running. Same type of enthusiasm here. See? He's constantly fiddling.
That bat is reliable, too. We begin to realize that we have to protect these environments because they have potential of having novel pharmaceutical agents in them. If we don't protect them, we will destroy them and we'll never have known they were there. Our children will have never known these things were there. It's said that we were burning the Library of Life before we ever had a chance to read it. I think caves are just a marvelous, amazing, they're almost spiritual environments. They're silent and they're dark, and there's a smell of mud and there's a drip of water, and it's just totally different from anything on the surface. And it's just an amazing environment. And as soon as I go down into a cave, I don't think about anything on the surface at all for 6 or 10 hours. Not until you come back out into the sunlight and suddenly you're back into the world of the living. Caving is definitely closer to nature. To me, it's like being up on, say, isolated on a mountaintop. You're real close to nature. You're down there and you can feel it. I'd rather go into a cave than I would go into church. Because I think you're closer to God in the cave than you are anywhere else.
One size bigger is what they use on litter, the oversized stainless steel aids.
Yeah.
And they call those a Jesus feeder. Because if it fails, Jesus is the only thing that's going to save you. I've been doing cave microbiology for about 8 or 9 years now. I was trained as a microbial ecologist. Now, an ecologist is somebody who's worried about relationships. And I was worried about microbial ecology, that is to say, little tiny relationships. Bacteria. I got a phone call, and it was from a Dr. James Bigelow. Okay, Jim Bigelow called. And he started the conversation with, "You're a cave microbiologist." Well, yes. And he said, "There are not very many people like you." And I said, "Well, that's very true. There are very few people in this miserable field, but, it's my field and I like it." And he said, "Have you ever tested your organisms to see if they produce any compounds that might be useful against, say, cancer?" I said, "No." Well, the second time you're kicked by a mule, if you didn't listen the first time, at least you ought to listen the second time. Caving is actually a sensual sport in that you're down against the rock generally. The rock is normally cool. Often there's mud involved, and anybody who's ever played in mud as a child knows that mud's kind of fun. One of the things that I like most about a cave is the quiet. Everybody knows a cave is dark, but often a cave is very, very quiet. You're not aware of all the surface noises when you're on the surface. It's sort of the background noise. But you become aware of it when they're gone. And you get it's a very peaceful feeling. Yeah, very nice.
Stop there for a sec.
Larry and Jim go to areas where they find what we refer to as multicellular organisms. They go so far back into the cave that the only thing that can survive are organisms like bacteria or fungus. And they go into areas of the cave where very few, even humans, have ever gone before. Larry, over the past 10 years, has developed a significant amount of expertise as to where life may be in what we thought was a sterile environment. And for the most part, we find bacteria growing where water, air, and land meet together. And at those points, Larry will put sampling devices, usually slides, and then comes back 6 to 9 months later and brings out those slides that he's put in place and begins to isolate bacteria that have colonized the slide that he placed into the interface of water, air, and soils.
This all set up. Ready to go back.
His next job then is to separate the different bacteria that are in the cultures that he's brought out of the cave. There can be one type of bacteria, there can be 5. Larry will take these pure colonies and grow them up in broth. And broth is simply a liquid-based food that the bacteria like to live in. So what we're going to do is we're going to take this culture that has the liquid food and the organisms and centrifuge it. We're going to separate the organisms from the broth so that when we have the broth, all that's there is the food plus any chemical that the bacteria has made. We add the broth that our bacteria have made to both normal cells and cancer cells. And what we're looking for is that broth that kills the cancer cell, but does not kill the normal cell. And if we can find that, then it's likely that that chemical is working through some difference that exists between the tumor cell and the normal cell. And if we can identify that chemical, then we'll have a chemical that's more selective for tumor and less damaging to normal cells. At the present time, what we know is we have broths that have selective activity. They're capable of killing specific tumor cells, and that is breast cancer cells. But we don't even have an idea what the chemical is that does this activity. That will probably take us another year to successfully isolate and obtain the structure of that chemical. We're looking at least 7, perhaps 8 more years of research before we'll have this chemical widely available for clinical trials. At the present time, we have enthusiasm about the potential, but we're a long way removed from being enthusiastic about the actual chemical.
I once told Miles that I finally found out what I want to do when I grow up. That was to be a drug development person.
It feels right, and that's what makes it easy. It's hard to believe that we won't be successful given what we have seen so far in terms of the diversity that we have out there, in terms of the targets that we can aim at, and in terms of how we can work together.
The real excitement we find in drug development is that we're allowed to do both basic science, applied science, and hopefully, as we've been able to, see the end result, and that is a clinically effective drug. Right now, it's probably the most exciting period of my research career, and that is that we've got new drugs, we've got new areas to investigate for drugs, and we have a lot of basic science to do to understand how these drugs work and make them better. So right now I'm as excited as I've ever been with the potential of our research projects.